GM, what's up, guys? Welcome to another episode of the Rollup. Today we have a great follow-up to our recent episode with Justin Drake on based sequencing. In today's episode, we chat with M-Team from Spire Labs, who is building the Based Stack. And we talk about what the Based Stack is and what based sequencing is, all of the intricacies and nuances about using the Ethereum validator set as the sequencers, trade-offs, and some of the value proposition of based rollups. Hope you guys enjoyed today's episode. Without further ado, first, a word from our sponsors. Enjoy.
Welcome to the Ignition, Mantle's newest campaign to liberate the growth power of Bitcoin. FBTC Ignition has officially begun with a total token supply of over 2,000 FBTC with a TVL of over 150 million. Right now, you can go on the FBTC website to see all of the featured campaigns, staking opportunities, and liquidity pools where you can utilize FBTC on-chain today for some of the best yields available on L2s. The Ignition Sparkle campaign can be found at fbtc.com/ongoing-campaign.
Welcome aboard on our journey into the singularity. This is the endgame roadmap for Frax and Fraxtal, the new L2 out of the Frax ecosystem that is totally based on fractal scaling. Fraxtal is a modular L2 blockchain built by Frax with modular and fractal scaling in mind. Fractal scaling is based on the Mandelbrot set of fractal images, and it explains how L2s become L3s and the entire appchain lifecycle goes through its evolution. The Frax ecosystem is made of some of the top builders in the space and has stemmed from its OG days of the Frax stablecoin. It is now in the LST space, the LRT space, and this Fraxtal L2 joins the existing suite of Frax products, including Frax Swap and Frax Lend. You can see Frax Ferry, the bridge to go from any chain, Arbitrum, Optimism, or mainnet into the Fraxtal mainnet, bridge your tokens, and bring your Frax assets into the Fraxtal ecosystem. Join today to get the best out of Fraxtal. You are still early. Join today. Take part in our expedition into the singularity.
What is going on, guys? Welcome to another episode of the Rollup. Feeling today particularly based and aligned. We're going to get into based rollups, in particular Spire. Today we're here with Matthew, aka M-Team. He's going to be audio only today. You guys might recognize his profile picture, which is we'll also have it on the thumbnail, so you guys can build some of that social recognition. It's his first time on the channel. Matthew, welcome to the Rollup, man. It's good to have you.
Robbie, appreciate it.
Absolutely.
Yeah, so I can give a quick background on myself. So I've been in crypto for about 5 years now, doing primarily MEV searching. So shadowy supercoder stuff, self-taught Rust and Solidity. So I'm a super technical guy, but happy to get into some of these non-technical conversations as well.
Awesome, man. Yeah, let's get pretty technical today on Spire. This is the based rollup stack, as you've coined the term. And so, maybe we'll start somewhat high level, but we'll go deep into based rollups today, talking about how Spire is thinking about based rollups from this stack perspective, some of the trade-offs with based rollups, and how you guys are designing the mechanism for what you're calling customizable composability. And I think this idea of composability, we had a chat with Jill from Espresso, who was coining the term like make Ethereum composable again. The rollup started out as DeFi Slate. And so we are very familiar with this idea of DeFi money Legos. That was core to the thesis in sort of the 2020 DeFi era. And so, I think there is some mixed feelings out there with respect to composability now. Interop, the entire user experience feels very fragmented. I think we want more composability than exists in the current implementation of Ethereum and its rollups. But maybe we don't get to full, gaming assets are interoperable and composable with the world financial system. maybe that is a little bit overblown in terms of composability. So in your perspective, maybe, we can start off, let's start off by talking about Spire. What is it? We'll get into how it works, and then we'll kind of talk about why it brings about the level of composability that it does. So a lot there, but first question is, what is Spire?
Yeah, thanks for the question, Robbie. As a high-level overview, we like to describe Spire and our core product, which is the Based stack, as a framework for allowing app developers to deploy based appchains. Right, so it's a based rollup that is application specific, as opposed to like a general purpose rollup built on Ethereum as a layer 2, and then we're also interested in exploring layer 3s in the future, right? And so we also have some auxiliary products which we can talk more about later that are we get into like pre-confirmations and stuff like this that augment the ecosystem. But our big play is the Rollup framework, right? The base stack, which is where we take app chains from how they exist today on things like Cosmos and take those to the next level with base sequencing, right? So there's a whole bunch of things we could explore, but I do really want to focus on composability as being an important reason base rollups are better than every other rollup, but also we can get into some other features that I think are super, super important to talk about here, such as bootstrapping, right? It's a lot easier to bootstrap a based rollup than another rollup with a decentralized sequencer set.
Cool. Okay, so maybe just one more like quick definitional or framing of this. Why, and this is a really basic question, why is a based app chain different from a regular app that is deployed on the L1?
Sure. Yeah. So let's kind of think about this from the life cycle of an application, right? So you have at first, if you're an application developer, if you are building just an app on a layer 1 or a layer 2, you will deploy your application, a set of smart contracts orchestrated together directly to that rollup. So you might interact with a RPC to deploy those contracts. That's a pretty straightforward process. You usually run through some configuration, initialization, and then you're up and running. There's no kind of external dependencies. You can use like all the features that are already set up for building apps on that layer. So these are things like RPCs. These are things like sequencers, which are built into layer 1s and layer 2s today. And also just things that are important for data, right? So you have indexing and things like this. Whereas if you're going to launch a based app chain, the difference here is that you're deploying a fully fledged rollup, which does mean you need to have nodes, you need to have indexing, you need to have a bridge and things like this that are important features of every rollup. This is a big part of like the kind of the modular roadmap here, that we think these kind of costs and infra roles will be competitive. Costs will trend towards zero. I know that's a big part of you guys' thesis. But I do really want to focus on that difference. Is like you do need to launch this infra or get someone to do it for you, right? That's an important difference. What's not different is the sequencing. So today, applications built on a base layer use the sequencing of that base layer, right? I think that's pretty clear to understand. With rollups today, you're moving to a layer 2, for example, and you're adding a new sequencer, right? Maybe you're using your own centralized sequencer. Maybe you're using another external sequencer from a third party. Maybe you're doing something in-house. Totally up to you. But the important thing is that you're not using the same sequencing as the base layer. Whereas based app chains and based rollups in general, we try to reuse the sequencing of the base layer as much as possible. And there's a few reasons for that. The big one is that we inherit properties that the sequencing of the base layer controls. And we can get into some of these, but I think the important ones are the network effect and state that lives on that layer, right? So if you're sequencing Ethereum and you're also sequencing a based app chain, and you can do shared sequencing between those. And then we can also talk about things like liveness, right? That's super important for some financial applications, right? So if you want the liveness of Ethereum, which is really, really good, then base sequencing is one of the best ways to do that as well. Now, you also inherit some negative aspects, right? So if your base layer is not system resistant, then your rollups will not be. If you end up having liveness problems on the base layer, your base rollup will also have those. And of course, block times is the big one that people talk about, where you do inherit the block times of the base layer that you build on. It's a limitation that's kind of fundamental to base rollups, but there are workarounds and some tricks that allow us to make that user experience even faster than what you might see on some other rollups.
Super helpful. Cool. Okay, so yeah, you laid out, kind of like what is the benefit of using the based sequencer. you mentioned network effects, state, liveness. All of these are normally more robust and significant on the layer 1 sequencer. And then also censorship resistance as well as this idea of block times, right? Which is a trade-off depending on the base layer. And so these are all kind of the considerations for whether or not applications are going to deploy their own rollup and with their own sequencer, or use the base layer as sequencers. And then the fundamental difference here between an app that's deployed on the L1 or an app chain that is a based app chain using the L1 sequencer is going to be all of the other infra that is associated with being a chain, which is RPCs, indexers, bridges. If you are just an L1 app, you don't really need to do all of that. You just inherit all of that tooling. But if you're going to be your own app chain, you need to build all of that bespoke, unless you use maybe like a stack, and we'll get into the base stack. So, okay, now I remember using 2020 DeFi. Like, I could just send my funds. Everything was Ethereum. Polygon and Avalanche started to pop up a little bit later, but for the most part, mainnet applications were on mainnet, and you could just send. You didn't need a bridge. You could just go pretty quickly. You could withdraw from one application and deposit into the next without any wait times, and everything was pretty composable. And that was part of what fueled DeFi, was the idea where I could take a LP token from Uniswap, go deposit it into a yield compounder, and get significantly more yield. And it had this flywheel effect that led to a lot of inflated yield. As in hindsight, right? It was great while it was happening. We were getting significantly higher APYs than we have now, but it was a result of much easier rehypothecation, which at the time was a feature. Now maybe we'll get into the customizable composability conversation, because I think maybe there was too much rehypothecation that led to kind of like the artificial yields and inflated yields. And so the user experience was a massive advantage, but it kind of had its own pitfalls. And so when you guys are thinking about composability between based app chains, there's a lot of infrastructure that you sort of have to navigate and coordinate between. So in your view, what is your view on composability? What is the right amount or right mix of composability? And then we'll get into like how that works in the base stack and how you coordinate amongst some of these different pieces of infrastructure.
Yeah. I mean, I'll start off this by saying that a very famous podcaster said fragmentation is sovereignty. And I think that idea, well, it's a little bit misleading, I think, at face value. There is some truth to that, right? As we get a more kind of fragmentation among an ecosystem, that also enables like more experimentation and more sovereignty, right? That's a good thing. But the fragmentation trade-off is still there, and is a very real problem. And so we do have to understand, like, how does composability solve that problem, and in what ways, is that like a important part of what Spire is building? So I'll start off this by saying that like mainnet is dead. There are very, very few applications that only exist on Ethereum layer 1. Like, I can think of a few, but not many. A lot of these big DeFi protocols are multi-chain now, and if they have not deployed in every chain, then there are forks of them on every chain, right? And so you do deal with complexity of a multi-chain upgrade or doing governance across multiple chains. Like, you can't just choose to opt out of the layer 2 roadmap of Ethereum, right? You do have to somehow touch those layer 2s, or else you're just missing out on the primary way that Ethereum is evolving and growing, right? And so I think that's a big thing to point out here, is that fragmentation is not just like a rollup problem; it's everyone's problem, because Ethereum is growing through rollups, if you like it or not. And if you stay on layer 1 as an application, then you just are not addressing the market that you could. And so it's a problem for everyone. And that's why we think that's an important thing to focus on. When we talk about composability, there's a few kind of levels of composability. We can get a little more technical here, I think, that we like to define. So these are all kind of like useful for different circumstances, for different users. I'd say we'll start at the top. We have what Justin likes to call synchronous composability, or universal synchronous composability. And the idea here is that this is exactly what a single layer looks like. So Solana has universal synchronous composability, which is just great for Solana apps. Ethereum layer 1 has universal synchronous composability. So does Base. So does all the layer 2s that you can name, right? They're all very powerful, but they're all isolated. This is isolated ecosystems of synchronously composable chains. Kind of the next step down is like, we like to kind of call it asynchronous composability, where we start to get into definitions of like composability versus interop. I like to keep it simple, say that there's like a somewhat linear scale of things that fall along the interop kind of landscape, right? So the most basic of this is atomic inclusion. And that just means you have multiple transactions on multiple domains, and then you can purchase like a crypto economic guarantee that each of these transactions will be included or none of them will be, right? And this is important for like instant bridging, some cross-chain swapping, like governance, doing governance upgrades across different chains, but it's not as useful as some other types of interop, right? And so we started to get into like, what if we had not just atomic inclusion, but also atomic execution? And this is useful for cross-chain arbitrage is the big one. But you also do like cross-chain contract calls at some level with this as well. So that is useful. Now, the problem with doing cross-chain contract calls through only atomic execution is that a smart contract cannot just like read a execution promise from a sequencer, right? Or a pre-confirmation, as some will call it, and use that within their code, right? They need like to be able to check that somehow, or have some larger guarantee that the chain won't just execute and then revert, right? Maybe you have a problem with your chain finalizing. This is a super real problem with Ethereum, right? Because we do have reorgs on Ethereum. Same thing on Rollups, right? It's totally possible to have a problem with like a decentralized sequencer or shared sequencer or something like this. So we have to figure out how do we like enforce that these chains are not only experiencing like atomic transactions, but the actual like settlement and finality of the chain itself is atomic, right? And that's where we get into synchronous composability, right? And the best way to do that we know of now is through validity proofs of some form or another, and proof aggregation. So there's like a single base layer or Ethereum layer 1 transaction that proposes a bunch of blocks, essentially, finalizes the sequences of those chains, and then submits a validity proof for each of these that aggregates all those proofs, which saves on costs, but is also means you can't just do one without also doing the other. And this is what some great teams like Aglair and Espresso are working on. But we think that is a super powerful vision as well.
Okay, so we've solidified a lot of definitions here, but let's talk about the Based stack, right? The main offering out of Spire. This is something that we see Rollups as a service providers really spurring like the proliferation of new rollups, applications launching their own chains, like again the proliferation of the appchain thesis, and sort of like not just one chain, not just like the alternative layer 1 thesis, but layer 2s, layer 3s, and appchains galore. Cambrian explosion, some are calling this. And we've seen the OP stack, we've seen Arbitrum Nitro, we've seen the Polygon SDKs, the ZK Elastic chain, and Ethereum has the ability for based rollups, but there's no stack. There's no and sort of setting the stage here for the based stack. Why has no one else come in and done this already? And what is special about the based stack from Spire that provides kind of the best of both worlds of Ethereum, and also maybe we could kind of compare this to the other rollup stacks that are out there from Arbitrum, Optimism, and the other L2 rollup stacks.
Yeah, great question. So there's a lot of things to unpack here. I'm sure we won't get into all of them today, so I will tell all of our listeners that we will be releasing our light paper, which is not very light. It's like 20 pages. And then a whole bunch of like articles as well in the next few months. So if you're curious about any of the stuff that I talk about soon, then please do take a look at that. You can follow the Spire Twitter, which we'll put in the description, hopefully. Yeah, so let's try to get into the what is the base stack, right? And then what is like the advantages of having a custom stack for base sequencing and for base rollups. And so at a practical level, and I'll give you like the real definition and not the one that we that like VCs and stuff. Spire is building a module that contains sequencing rules, and that's it. So this is it essentially means that we define a few things about sequencing and then leave everything else up to another rollup stack, right? And so when we launch our kind of full product, not really mainnet because we're not actually running anything, but we launch appchains on mainnet, right? We will launch with a fork of the OP stack. So we take the OP stack how it is. They have fraud proofs. They have bridges. They have a ton of like infrastructure that's built for the OP stack, and that's amazing. And then we just attach like a little module on top that makes the OP stack so much more powerful, right? And so instead of calling this a sequencer module, like you might see some other like shared sequencer teams doing, we decided to just completely call it the base stack because it is so different that it's almost not worth a comparison. And so it's kind of different flavors, I would say. So let's talk a little bit more about sequencer rules. So I talked before about composability and like synchronous composability. All of that is what's being fed to people right now by researchers and by some of these other teams. I want to make it very clear that like ZK and real-time proving and what we need to get to atomic execution and proof aggregation and things like this is a ways out, right? I've heard estimates from people of a year. I've heard 10 years, right? No one really knows when this is going to be live and when it's going to be like production ready and battle tested. But we do know that like we can get a good way of the way there with some tricks, like some almost some shortcuts around some of these problems that we are experiencing. And so that's our product, right? That's their big differentiator from some of these other base rollup names. We can talk more about kind of what the sequencing is. I'd say like primarily the idea is that base sequencing is reusing sequencer election of a base layer. So if we say Ethereum sequencer election is proof of stake, right? We randomly elect using some kind of coordination between nodes to decide on a seed for randomness, a validator to be granted proposal rights for a single block. And we do that like 32 validators at a time, but there's some technical details there. But the big idea is that there's a few like defined set of rules for how this one proposer comes to be, and that's based on proof of stake. Now, there's other sequencer election rules out there, like Base has a permanent sequencer. So does OB mainnet and a bunch of other rollups today. And there's some other options as well. I think the important thing to look at here is like, this is the way that we elect a sequencer. But the actual sequencing and the sequence of transactions that ends up being confirmed is a whole different thing to talk about. So Spire actually focuses on both, which is very different from some of the approaches that some other base sequencing teams take. I think that's where we see that like 10x improvement over existing rollups as well. So I'll start with sequencer election. I define a base rollup as a rollup that uses base sequencing, which I define as sequencing that inherits or uses as a foundation the sequencer election of another base layer, right? And so for us, that means using Ethereum. Right? So Ethereum has their sequencer election. We just reuse that, right? We add some like little jingles on top to make it more friendly and more cost effective, but that's kind of the starting point, right? And this too means we inherit a bunch of things, a bunch of the qualities of Ethereum that I mentioned before. But it also, some of the things that we add on top enable like MEV retention, right? So base rollups are not Ethereum aligned. I hate to break it to all of you people out there, but we are app aligned, right? We're not Ethereum aligned. And so I think the thing that we should start to get into as well is like, what is the other part of sequencing? So we talked about sequencer election a bit, and this is the big focus of shared sequencing, but there's so much more to it than that, right? This is one of Spire's like primary focuses, which we do dive into a lot in the light paper, which is that the sequence of transactions that's actually produced by a sequencer is arguably more important than like who is the sequencer, right? Like nobody cares who's sequencing the transactions. They care if their transactions in, and if it's cheap, and then what it can interact with. What is like the interop and composability that we enable here? And so that's a thing that I'd love to talk about. We call this customizable composability, which is a specific feature of the base stack where we modify the sequencing rule. So what is like considered a valid sequence of transactions, and define it as only a sequence of transactions that meets some criteria that is actually set by the application. So there's a easy onboarding process you can go through to say, I want my customizable composability to apply to NFTs on Ethereum layer 1. So maybe only the CryptoPunks contract. Or maybe you say only Uniswap pools, right? Only these 10 Uniswap pools. You save costs from interacting with the rest of Ethereum. And what ends up happening is that you define like a special function that is run on your rollup contract, and that produces some result. And that result is like must be the contents of the first transaction in your rollup block. And so therefore, every other transaction in that rollup block can view like what happened in that first transaction after it writes to a contract. And I know that's a lot of words, and there's more technical stuff in the light paper, but the big idea here is that we allow application developers to define exactly what they want to know about Ethereum, and then every transaction in their Rollup will have real-time read access to this. And so, just like a simple example, Oracle is on Ethereum. So you want your Chainlink data feed, you want your Uniswap price feed, then you can get that on a Based Rollup with like barely any configuration. We think that's already like a super powerful kind of idea that we haven't seen any other games exploring as of now. That's something that Spire is really hoping to pioneer.
And so this module that contains the sequencing rules are those rules that when you say the top of the block and then the rest of the block can see that, access it, view it, read it, and use the information for the sequencing of the rest of the block. Are these the instructions, or what? Do you have to grab data from the rest of Ethereum, or could you just kind of talk a little bit more about exactly what happens at the top of the block? I think the rest of it is pretty straightforward, that it reads what happens at the top of the block. But yeah, could you just kind of really, because I correct me if I'm wrong, but this is kind of the special sauce of Spire. It's what happens at the top of the block for the rollups that are deployed with the based stack. So could you kind of dig into that a bit deeper?
Yeah, for sure. I just want to say that there's a ton of features of the base stack that we like to talk about. This is one of them, and I think it's one of the coolest, just frankly. And so I'd love to spend some time on this, but we can also talk through some of the other features as well. So let's get into the technical bits. So we allow application developers to define a sync function, which lives in the rollup contract. And every time a rollup block is proposed, then that sync function is run by Ethereum. So it's like by code executed on Ethereum layer 1, which is expensive, but it's only run once for every user of the application during that block. So the actual marginal cost for users is not super high and can be even more amortized across a network of Based Appchains, right? And so I just want to put that out. And then then we have like the result of this execution. So this is just some like bytes, some object that represents what happened during this execution. And so maybe you read from an oracle and your response is just a number that says ETH/USDC is 3,000, right? And you know that. And then you move this into kind of the way that rollups actually work today. And we can talk about like optimistic rollups versus ZK rollups. But the idea is that they have some derivation rules, which allows them to define what is considered a valid rollup block based on the state of the layer 1. So you're deriving your state from layer 1 state. And so one of the things that you can see about layer 1 is this event that occurred that kind of described the result of executing the sync function. And then the actual rule itself is simple. It's just, does the result of the sync function equal the input to the first transaction, like the very first transaction in a rollup block? And so let's kind of back up here and put some terms. We call this first transaction the sync transaction, or the sync TX. And then this like interacts with a contract on the layer 2 or anything on the layer 2 really, and can save state. So maybe this sync transaction has the result of that ETH/USDC price we mentioned earlier. So the kind of the call data for this transaction is just 3,000, and we enforce that in like the rollup derivation rules. And this is like kind of directly applied to a contract. We call it the sync contract on the layer 2, who stores this in memory and makes this accessible for the rest of the transactions in that block to happen. So you could do kind of long-term storage here. You could do a short-term storage as well. But the big idea is that you have some real-time access to Ethereum that is like enforced by the actual derivation rules of your application itself.
Got it. Awesome. So that's how this app chain, albeit still has its own infrastructure, but because it uses the sync function that reads the data or the state, it reads the state from the L1. It sort of encapsulates it into the sync transaction, and then the rollup is able to read that through the sync function, understand its call data, and then check to make sure that it matches. If it does match, then it uses this call data for the rest of the transactions in the rollup block, and that's how it orders the transactions and maybe reorders based on what is contained in the sync function on the rest of the layer 1.
I wouldn't say orders. I would just say executes. So maybe the result of your Oracle call is like I said, $3,000. You could store this in a contract, in the sync contract, and this would be readable just like any other contract. So maybe you deploy your application, and instead of like reading from a kind of like an Oracle buffer or whatever you use today, you read from the sync contract, and you just know that that's some reflection of Ethereum state.
Got it. Okay. Yeah, that makes sense. And one other question I wanted to ask you was, you mentioned that this function runs on L1, which is costly because it runs on L1, but it can be amortized across all of the users on all of the based rollups from the based stack. And I was curious if this means that that one based app chain like that is launched with the base stack is somewhat dependent on another based app chain that's launched on the base stack, because they both use this sync function at the top of the block and they sort of share that. Is that, I have a feeling that's not the case, but could you maybe explain why?
Yeah, so I mean, we feel really strongly that app chains should maintain sovereignty. So we don't go down this like shared sequencer route where we demand that you must opt in and give us some sequencer revenue. We think that's silly. We understand that there's like different like levels of opting in, and the espresso guys are great at explaining this, where they say like you don't have to give us all of your sequencing rights, just a little bit. We say like we will take all of your sequencing rights and give them to Ethereum. We're not going to keep it 10% for ourselves. But the other thing that you can give us is like your blobs. So maybe you're running TA and you'd like to share a blob with another app chain. We'd love to coordinate that for you. It's called like blob sharing or blob aggregation, and we have some more research on that coming soon. So I think that's something important, is like as we build more based app chains, there's a network effect that we get just from that coordination that it just isn't explored right now in something like the superchain. So you mentioned like the sync function. Let's talk about that a little more. So based app chains and then based rollups in general are expensive. I could put some numbers here, but essentially you're paying thousands of dollars every day to keep this app chain running. But the nice thing here is that this scales sublinearly as you increase the number of app chains. So maybe you start off with one app chain that bears all of the costs, but then when you add 10 more app chains, each of them bears that cost somewhat equally, right? And so you end up having a much cleaner kind of experience here. So everyone's paying less. It's good for everyone. This is the kind of incentives and coordination games that we like playing, and that means like everyone is happier. Now, when we talk about like I mentioned sovereignty at the beginning of this paragraph, but the idea with sovereignty here is that every app chain is still running on their own contract. So they still have like a rollup contract that is separate from every other app chain. But the kind of sync function and some of that can almost be shared between app chains. So if you propose a block as a sequencer for multiple app chains at the same time, so we talk about shared sequencing, right? Then you can also kind of run these sync functions together at the same time, right? And if the sync functions are exactly the same, then you don't need to re-execute them. So if theoretically, just by coincidence, two chains were trying to get the same oracle at once, you would not need to re-execute that twice. It could just be kind of almost enforced once, right? You execute once and enforce across all of these domains kind of individually, I guess. And so that's where the cost saving comes through with the sync function, is that you have the same sync function to run, and then you don't need to run it twice. Now, we expect sync functions will look very different for every app chain. So there will be a cost saving for every app chain. But there are components and modules of this that wouldn't have to be re-executed multiple times. So we think that's a really important thing to look at as well. I think there's like a whole bunch of paths that we could go down here about like how expensive are based rollups today. What is like the cost structure of Spire based rollups compared to some existing stacks? I'll give you a hint, we're a lot cheaper. And we can talk about some of these as well, but I think we should leave that to another conversation and maybe talk a little bit more about what this means for Ethereum. So happy to go in that direction, I guess.
Sure. Yeah, would love to talk more about the network effects from blob sharing as well, but I have a feeling again like that's something that let's leave that again for another conversation. Let's talk more about like what impact this has on Ethereum and the based rollup ecosystem.
Yeah. No. Okay. So I just want to start by saying that there has been a lot of kind of based rollup information from the EF and Justin Drake and some of these people, where we talk about based rollups leak MEV to Ethereum, and that's not true. Like it's totally possible to implement even like a deterministic sequencing rule for a based rollup, so you don't leak any MEV to anyone. or you can add sequencer election gadgets to save MEV as a revenue, right, for the app chain. With the base stack, that's like a 5-line configuration change. So, that's one thing that we strongly support. But the big idea is that you don't have to link your MEV to layer 1. So base rollups do not return MEV to the layer 1. And I know Kyle Samani will be sorry to hear this, but this doesn't make the ETH bull case better in that regard. Now, what it does do is it increases usage of layer 1. So if you look at Etherscan now, Tycho, a live base rollup, is the third and fifth largest consumers of gas, right, of block space on Ethereum, which is pretty crazy to think about. But something we think about here is the Ethereum ecosystem being made better by base sequencing and by the additional economic activity that is enabled through scaling in this manner? Is this just better for ETH as an ecosystem anyway? And we think yeah. And so that's something that we like to kind of promote as the base rollup narrative. Is let's not think about MEV as being a check to the validator. Let's think about the additional economic activity that's unlocked here, making even the layer 1 state more valuable. So maybe you end up extracting more MEV, but it's because Ethereum is actually being improved, right? Not because you're extracting value from applications and being unfriendly in that regard. And so this is kind of our thesis. There are some things that Ethereum can do to make itself better for base rollups. I think that's probably better left for another discussion. I think shorter block times are one example. But the big idea here is that base rollups are really good for Ethereum, better than other rollups, because they improve the access to Ethereum state, right? They get more people touching Ethereum every day, and that is super powerful for the network effect of Ethereum itself. It's something that we believe is it's not going to end up in a direct check to the validators unless we get into pre-confs, but that's another story, and is going to end up actually resulting in just a strong strengthening of the Ethereum L1 itself, as well as the whole ecosystem of base rollups.
Vertex Edge is now live on Say Network. Say users can now trade 50 plus spot and perp markets with the unified order book liquidity of Vertex Edge across Arbitrum, Blast, Mantle, and Say. The next 6 weeks, 850,000 Say tokens will be up for grabs as trading rewards every single week, exclusively on Say. Join Vertex on Say Network now on Vertex Edge. That's vertexprotocol.com.
Let's just briefly touch on pre-confirmations and kind of how you're viewing that. You say that pre-confirmations end up with a check to validators. I'd love to hear more about what that means. And then you also mentioned a little bit earlier about Spire having some of these auxiliary product offerings, if you will. One of them being take on pre-confirmation. So yeah, we'd love to dig into the pre-confirmation take in general, and then how Spire approaches this.
Yeah, I know for sure. So I have a ton of thoughts on this. I've been deep into pre-confirmation research for a while. I just want to make it very clear that there are different types of pre-confirmations. There are layer 1 pre-confirmations and also based pre-confirmations. Layer 1 is pre-confirmations for transactions on layer 1, and based is for transactions on based rollups or layer 2s, right? There's a really, really important difference here. So there's a bunch of teams building layer 1 pre-confirmations. There's a bunch of teams building based. There's some doing both. But the idea here is that we care about based pre-confirmations. The reason that could end up with a increased staking rewards for validators is because if they opt in to providing pre-confirmations through any of these pre-confirmation protocols that exist, then it's very possible that they will end up producing a more value than they would today, right? So they're providing an additional service that users are willing to pay for. As a quick example, we did the math and we estimated that if every user on Arbitrum, if they paid 1 cent more per transaction to be included instantly, then the staking rewards of an Ethereum validator would about double, right? If about, I think, 30% of validators were opted in. So don't send me on those numbers. But the important thing here is that we have this understanding that pre-confirmations, if users are willing to pay for them, can be a big revenue driver for stakers. So let's talk about what does it mean for Spire? So we're really bullish on some of these pre-confirmation protocols out there. I won't name drop anybody at the moment, but we're talking to a ton of teams, and we're really excited about what they're building. We're not building our own pre-confirmation protocol, so some of these teams can do it better than we can. And so we said, why don't you guys use it, and we'll just let the market decide what kind of pre-confirmations users want, and then we'll just make the base stack like compatible with all of these at the same time. And so it's kind of permissionless market competition is what we kind of promote and incentivize here to give users like the best of the pre-confirmation protocols that exist. So that's something we look at. In terms of our auxiliary products, we think pre-confirmations are not like super important to base rollups. I think they're less important than maybe Justin Drake does, but they are important enough that coordination from like one central team on some of this will be nice to kind of get some of these pre-confirmation protocols to work together. And also to just make pre-confirmations friendly to users. So you don't want to have to install a new wallet to use pre-confirmations, do you? So that's one thing that we solve. And so I think kind of a more technical dive into each of these would be better in the future, but that's a quick primer. So we introduced something called the pre-confirmation registry, which is a kind of validator or staker facing product that allows pre-confirmation protocols to use collateral and kind of slashing rules together. So they don't need to build their own registry. And kind of allows for a unification of some of these things. So this is a open source public good. We don't make any money off of the registry. And then the pre-confirmation RPC, formerly known as pre-confirmation gateway, a little naming mix up, with some things that Justin worked running. I did coin the name first. I'll just tell Justin that, but he went out in the research now. So yeah, you can go on ETH research and find some of the things that I talked about here. But the big idea is that we want to abstract pre-confirmations from users. So as a user, I want to see a green check mark in 100 milliseconds. I don't want to install a new wallet. I don't want to, do something. I don't want to like have another gas slider in my wallet experience. That's a terrible UX. We're trying to make UX better here, not worse. And so we said, instead of spinning up like a new wallet or setting up a front end to do this, what if we just had users send their raw transactions today to a special RPC that gets pre-confirmations for them on their behalf. And that's all it is, right? And so this pre-confirmation RPC takes transactions, does some math to figure out how much MEV they leak, does pre-confirmation tip pricing and some other complicated stuff that we provide as a service to users. And then we route those kind of packaged up pre-confirmation requests to pre-confirmation protocols. So anyone that's integrated with us, go ahead. All the code will be open source, so easily forkable. Anyone can run this. We will run one at the start, just to make it easy to kind of bootstrap some of these base rollups. But that's kind of the big idea with our pre-confirmation RPC is like, how can we take the actual user experience from 1 to 2 instead of 1 back down to 0?
Given that you're open sourcing this RPC and these RPC providers are making money hand over fist, one of the few crypto projects that are making money in the ecosystem along with these rollups. Do you have any concern? Are you thinking that maybe the likes of Infura or Alchemy could kind of take this idea and send their order flow through to validators that are providing these pre-confirmations, or is there an integration opportunity, or how are you thinking about users switching over or integrating with existing RPCs? Cartesia is your home for app-specific rollups. At the forefront of developing new tools and platforms that enhance the capabilities of blockchain technology, Cartesia enables applications that are flexible and built to scale. Build on a full Linux environment and use traditional software libraries, but in blockchain development. Go to cartesia.io, that's cartesia.io, to learn more about building your own app chain today.
For sure, yeah. So value, accrual, and moat are like a much longer discussion. We have a very different take on this than some other rollup stacks, even just every team in crypto, I think. So we should definitely talk through that. But just kind of overview of this specific question. The RPC itself is an open source product, but there are some contemporary algorithms that we developed that are about MEV and pricing pre-confirmation tips that make it harder to fork and outcompete us at day one. we fully expect that the dark forest always wins, and we will be outcompeted eventually. But that's where we kind of fall back to the power of defaults. So if you do spin up a based app chain and you see different options out there, but the default is the Spire pre-confirmation RPC. So whenever users switch to a based app chain, they automatically have the Spire pre-conf RPC. That does go also a good starting point. There's also some research that we've done internally that shows there's a pretty big advantage for the more transactions that you see, the better you are at pricing every one of them. So we'll not only be able to be the default, but also if you do the data, I think you'll be able to see that we end up pricing some of these pre-confs better than other options. With that being said, it's not our specialty. Our specialty is building a deployment option for applications that is better than anything we've seen so far in crypto. And so that means that we're more than happy to outsource and coordinate some of this work. We do have an internal team working on it, but we're also more than happy to look into integrations with some of these other teams as well.
Awesome.
Yeah, I wouldn't phrase it like competition at this stage at all.
Right. Yeah, no, that makes sense. Cool, man. Well, I mean, I think there's, you left plenty to be desired, but I think we went really deep here, and this has been a great primer and introduction to based rollups, but also to Spire, and has really set the stage for what's to come in the Ethereum ecosystem. And so, yeah, appreciate you coming on and giving me some renowned hope on the future of Ethereum. I think it's still bright despite what the Twitter trolls are saying. So appreciate you coming on, man.
Yeah, sure, no problem. I'll just kind of finish this part of the discussion by saying that base rollups are a amazing option for application developers. And if you're building an app, or you're thinking about building an app, or you already have an app, then please reach out to us. We'd love to do some market research and understand your specific desires and how we can help you. I think there's actually people don't realize this yet, but base rollups are like the Solana killer. We introduce a unified Ethereum, right? And we have a bunch of marketing material, but I'll save that for later, where we talk about, bring the applications home to Ethereum, right? And then we kind of understand that this a strength, right, and a coordination in a time of need looks like the Constitution for America, right? Beating out the Articles of Confederation. So this is like the bankless narrative, I'm sure. But we think about this as being super important to the future of Ethereum, but also just the future of crypto, right? I think there's a lot to still be exploited, and a lot that we need to prove, and a lot that we are going to prove, but you'll have to wait and see about that.
Absolutely. Looking forward to hearing more about that and having some more conversations. Awesome, Matthew. That was a banger. Thank you so much.
Sure. Yeah, no problem.